Hi guys, I'm going to make a video now. As I said today in class, I will be recording this in English. This is the worked examples that I go through in class on the document camera there, and I'm making these videos so that you guys can watch it afterwards again. But it also, yeah, anyway, okay, so let's get started. There's no script, so you're going to hear a lot of and ahs and maybe pausing and scratching out, making mistakes, but that's part of life. So let's go through the example that I did today in class, and that was example 3.1. So we are going to do example 3.1 on page, what's this? Let me just check. This is page 82 in the textbook. So page 82 in the textbook. All right. And the idea is that while I do the example for you guys on piece of paper and scan it in, I might as well record my voice while I do this so that I can explain some of the steps. Okay. So first things first, let's always draw we're always going to draw the circuit out so that we can label exactly where our unknown voltages and currents are. And that, as I said to you guys, I emphasized to you that in tests and exams, that makes it much easier for us to mark it. Okay, so let's start with the circuit. It's plus minus Vs. And this is 120 volts. So we have here, we have a 4 ohm resistor. Let's call that R1. R2 over here is equal to 18 ohm. Then we have R3 over here, and this is a 3 ohm resistor. And I'm going to go down, and R4 is equal to 6 ohm. Okay, so as I said, this might be different to, there isn't, I think, in the textbook labels for these resistors, but good practice always to add labels, because you'll see that we're going to keep our derivations in symbolic form as far as possible, and that will make things easy. What I'm drawing over here is just a ground symbol. I think I explained that also in the class. Just the reference point in my circuit. Okay, so first thing what I would like to do is I want to calculate this current that I'm highlighting over there, this current IS. How am I going to get this current IS? And the idea what I'm going to do is, like we learned today in class, is we would like to start simplifying this circuit to get it into a very simple form that's shown over here, which is R equivalent. And then we have IS flowing over here. Okay, so the question is, what is this value for R equivalent? And what we're going to do is we are going to use the series and parallel. Ooh, I don't know if that's spelled correctly, but doesn't matter. Series and parallel simplifications that we learned today. Okay. Now, first things, let's look at this simplifying these two resistors over here. These are resistors in series. Let's call it RA is equal to R3 plus R4 is equal to 3 plus 6 ohm, and this is equal to 9 ohm. Okay. Now, essentially what we have is we have reduced or simplified our circuit to now look like this. And I'm not going to add all the values. As you can see, this is R1, and this is R2, and this is now RA. Our simplified resistor values over here, where I've just added 3 and 6 to make that 9. Okay. Now, what can I do to simplify things over here? I can call this RB, and as you can see, this is resistors in parallel. R2 and RA are in parallel. Why? Because the terminals, the terminal voltages over each of these resistors are equivalent. So that's why these two things are in parallel. Okay, so to simplify this into a resistor called RB, I'm going to use my parallel resistor equation that we derived in class, and that I think all of you guys should understand pretty easily. Okay, and this is R2 times RA over R2 plus RA, and this is equal to R2 is 18 ohm, so 18 plus what is RA? 9 divided by 18 plus 9. Okay. Oh, this is times. Sorry. As I said, there's going to be some scribbles over here. So 18 times 9 divided by 18 plus 9. And to do that, I'm going to take out my calculator. This is 162 divided by 27. And this is 162 divided by 27. This gives us a value of 6 ohm. Okay, something important that I said today, just a sanity check, is that the parallel combination of my resistors here, RB, so I calculated this as 6 ohm. What is R2? R2 is equal to 18 ohm, and RA is equal to 9 ohm. Okay, so I'm going to highlight those. This values. So this 6 ohm, this value that you get for the resistance in parallel should be, this 6 ohm should be smaller than the smallest value of the resistors in that you're adding. Okay, so this, as we can see, this is the case. This is the smallest value is 9 ohms, so 6 is smaller as 9. Sanity check, everything seems to be okay. All right. So now, what have I what have I essentially got? Now my circuit is reduced to R1 with RB over here. Oh, I'm getting very close to my goal of an equivalent circuit that looks like this. So I've got the value for R1, I've got the value for RB. And essentially from this I can now derive, R equivalent is equal to R1 plus RB. And this is 4 ohm plus 6, and this is giving me 10 ohm. Okay, so now I've got my value for R equivalent over here, and this is 10 ohm. And I have my value for Vs, this is 120 volt. So I'm going to go on in this part over here to avoid moving over to a new page. So let's just create some space over here, guys. Okay. And close it off like this. Close it off like this. So that we keep all calculations nice and separate. Okay, so over here I'm going to do a bit more calculations now. First calculation. Let's calculate the value for IS using Ohm's law in this very simple circuit over here. So RS is equal to 120 divided by 10 is equal to 12 ampere. Okay, that is our first answer. Now we've got the total current flowing through the loop. So as I said, I've got this IS over here. For me to solve this circuit, to calculate the voltage over any one of these resistors, it would be excellent if I can get the value I2, and let's call this I3. So if I'm going to highlight these currents over here, I would like I2 and I would like I3. Okay. Now the question is, how are we going to do that? Well, let's start looking in this. Let's look in this loop. Let's see if I can calculate the value of I2. I already have the value of IS. Then I can probably apply Kirchoff's current law at this node A to get the value of I3. And if I have the value of I3, then I can calculate the voltage over the resistor R3 or the voltage over the resistor R4 pretty easily just using Ohm's law. Okay, so the question then becomes, how are we going to calculate this value for I2. Okay, what we can do is, if we look at this part of the circuit, we can probably apply Kirchoff's voltage law around this loop to calculate the voltage at this point, plus minus V2. And let's just highlight that a bit so we know where we are. That's plus minus V2. And I know that my polarities are going to be like this because I2 is flowing down through the resistor, causing a voltage drop, plus minus V2 over this resistor R2. Okay, so how am I going to get V2 over here? Let's apply Kirchoff's voltage law through this part of the circuit. So we're going to start. We're going to say that the sum, well, firstly, we should write down KVL, Kirchoff's voltage law, for loop 1. Okay, let's underscore that so that we know exactly what we're working on. And I indicate this in my circuit. Got a little loop sign there. Okay, so I've got Kirchoff's voltage law for loop 1. Let's say the sum of all the voltages in my loop is equal to 0. Let's start walking around my loop. We're going to see Vs plus Is for Is plus V2 is equal to 0. So V2 is equal to Vs minus 4Is, and I have Is, so this simply becomes 120 minus 4 times 12, and this is equal to 72 volts. Okay, so we have 72 volt flowing over there, and from that we can calculate the value of I2. So I2 is just V2 over R2 by using Ohm's law in this part of the circuit. And this gives us 72 divided by 18. So I have I2 is 4 ampere flowing there. Okay. Now, how am I going to get I3? To get I3, I'm going to apply Kirchoff's current law on node A. This is node A over here, as shown there. Highlight my calculations over here, and this is what I'm going to do in this part now. What does Kirchoff's current law tell us there? We're going to have to decide on what we're going to do. What sign are we going to attribute to currents going in or out? Okay, so let's say that currents going out is positive. Kirchoff's current law then tells us that the currents, all the currents at a node, the sum of all currents entering and exiting at a node should be 0. Okay, so, and we're going to say that all currents that goes out is positive. According to my convention or my sign assumption that I showed in my diagram over here, I said I2 is going out, I3 is going out, and Is is going in. Okay, so this becomes Is is equal to I2 plus I3. So I3 should then be Is minus I2, and this is, what is Is again? Is 10 minus 4, so no, Is is 12, sorry guys. Is is 12 minus 4, or I3, sorry. I3 is equal to Is minus 2. Is is 12 ampere, I2 is 4 ampere. So let's write that a bit neater. I3 is equal to 8 ampere. Okay, now that I have my currents, I have all my currents. I have I3, I have I2, and I have Is. Solved all of them. So Is, I2, and I3, I can calculate using Ohm's law the value of any voltage over those resistors. Okay, now if you guys want to do a check here to make sure that everything is working out well, and I'm going to leave that to you for the exercises, is calculate the power that is supplied in this circuit and compare that to the power that is dissipated in the resistive components. Those two should be equal. Okay, that's it for this example. I'm looking forward to getting feedback from you guys regarding how well this video worked or didn't work. But in any case, I'll see you in class. Thanks.